I'm Dan Tauka. I'm a partner solutions architect with AWS. I've been here for about 4 years. As a solution architect, I work on the ISV workload migration program, and then I'm also an AWS HashiCorp ambassador. So today I want to talk about the shift in mindset that happens when you migrate your workload to the cloud, and specifically to AWS. So we'll take a look at secrets management, what that looks like, what that looked like before the cloud computing area. We'll talk about the change in mindset that takes place when moving to AWS. And then we'll wrap up with some key takeaways as you develop your secrets management strategy in AWS, how to do that properly and securely. So first of all, why is secrets management important? Why should I care about secrets management, right? I think it's probably obvious. We would all agree it's important to protect your sensitive data, protect your company's secrets, intellectual property, and of course, just in general, privacy is important. But let's ask ourselves if we've been doing the right things with regards to secrets management. What are the mechanics of doing this? So let's go back a bit. If you're like me, remember running your infrastructure in a data center, or maybe you are running in a data center now. In that scenario, you're responsible for all of that end-to-end security. So how is this done? First, we set up our boundary, right? We rack and stack our servers. Maybe we build out those servers, build out some applications. You have data centers, offices, people working from home or on the road. They all have workstations or laptops. And then for that physical perimeter or access to these areas, maybe use badges. Employees have fingerprints. They use their passwords, maybe have multi-factor authentication enabled, all to protect access to these areas, right? In conjunction with that, there's firewalls. You decide who has access to what. What are the IPs? What are the ports or MAC addresses that are available to access these systems? Maybe you have an IDS, intrusion detection system, with agents that scan traffic looking for intrusions or attacks to the perimeter. Maybe you have a SIEM to log events, device logs, VPN logs, sys logs. You get alerted when there's an issue. But how do you correlate all this data? You probably have to put your detective hat on and do some research, right? You have endpoint protection, antivirus, anti-malware on your servers and workstations. And then maybe you have certificates for public websites or client-to-server communication. So the ultimate goal is to make sure that everything in this boundary is trusted and secure. And if we look at this, what are some of the common themes here? We set up a perimeter access control, right? We use IP addresses, ports, MAC addresses to identify traffic. We set up trusted and untrusted zones. And that's kind of how things were done before, right? But there's challenges with this. How do you maintain the security of your on-premises infrastructure? What are some of those challenges? Well, the first one is lack of visibility. In an on-premises environment, it can be difficult to know what resources and data are out there. Where is that data and where are those resources moving? Who's accessing it? Who's utilizing it? There's expensive tooling that can help you get an accurate real-time asset inventory, but it's complex and expensive to implement. You have multiple systems, multiple interfaces, multiple or no APIs within these systems. It's difficult to get visibility for all of these systems and logs to get a single pane of glass. You might know where people are coming in and out, where they are in that building, right? It's the same thing with the firewall. Once they get into an environment, where are they going? What are they doing inside the system? It's not impossible, but it certainly is challenging. And many organizations just don't have the level of visibility that they would have in an on-premises environment. And without that visibility, it's challenging for organizations to adequately secure their infrastructure and their data to meet their security and compliance requirements. There's also a low degree of automation. Another typical challenge that I see is trying to get rid of those manual processes that are employed to remediate issues. Think about copying and pasting information from one tool to another, or manually applying patches. It's been difficult to automate some of these key security tasks due to issues like interoperability of third-party or homegrown tools, lack of APIs or automation. How do you connect these different systems? How do you synchronize data? This is difficult to automate, it can be challenging and expensive. And manual processes, they tend to lead to inconsistent execution, longer wait times to address all systems, Some cases, it can disrupt the customer experience. So the goal of automation is to programmatically handle tasks that would otherwise be manually done by IT staff. So as we start to talk about the cloud, we'll see that this is a little bit easier. But this combination of lack of visibility into the environment, coupled with the low degree of automation, that can compromise an organization's ability to move quickly and effectively secure their on-premises infrastructure. This can also result in impacts to secret management. What are some of the things here? We have, maybe unreliable rotation. This can cause outages. There's no clear audit due to decoupled systems. It's harder to track activities, resulting in too much human access for that just-in-case scenario. Long overdue secrets never get rotated. Complex solutions, need to be put in place for that secret rotation. How do you do that secret rotation? Is there human interaction? This is complex to build out, and we fall behind, right? Maybe we're doing these rotations once a month, maybe quarterly, maybe yearly, maybe not at all. How reliable are they? How are we patching and rotating? Are we breaking things? Did we change a DB password? Maybe not all the servers get updated with the new password. This can also result in outages. And then there's complex and interconnected systems, and there's really no clear way to do an audit. We're not really sure who has access, who has visibility to these secrets. Maybe a manager has access to all the passwords. Are we giving too much access? Probably. Maybe someone leaves the company and still has access. There's a lot of times no clear audit trail. And a lot of times too, maybe just too many humans have access to this information. So before, organizations were kind of forced into this binary trade-off. Either you moved quickly or you stayed secure. Right? In your organization, people are requesting new applications. They're building new applications. They need access to this system, to that system. People want to move fast. They want to innovate. They want to provide solutions for their customers. But at that same time, if we want to stay secure and have security processes in place, we're often forced to slow things down to a human speed so that we can ensure the overall security of the organization. So previously we had to choose. Either we stay secure and we do things slowly with a lot of potentially manual work and approval processes, or we move fast. And when we do that, we potentially violate guardrails that are put in place just to get out those releases quickly to your products and solutions to your customers. That paradigm has shifted in the cloud. So today it is possible to automate a lot of these basic security tasks like patching and rotating of certificates, rotating of secrets. And with the right tooling, you can gain visibility needed to accurately identify and monitor those critical assets and data within your environment. With the cloud, all of this is made easier. So you can stay agile while maintaining, and in some cases, improving your security by providing highly integrated logging and monitoring, as well as integrated tools to automate core security functions. You can use AWS to innovate quickly while still maintaining that security posture. So we're seeing that customers want to offload their experience, their workloads to AWS because they want to move fast and quickly. They want to iterate quicker, deliver value to their customers and clients. While at the same time, they expect to have that secure environment that can scale to the rapid pace of their innovation. So it's no longer binary. You can do both in AWS. So we changed then to how exactly can you do secret management in AWS while still staying secure and moving fast? So it is a change in the question, not why I care about secret management, but what should I care about? I know a lot of people have hands-on experience with AWS and HashiCorp tools. I'll save the HashiCorp tools for Michael, but I will dive deeper into AWS, what we have, and kind of some of the things that you can leverage to make that security, identity, secret, and compliance a little bit easier. So how can you make your AWS environment secure? Well, we have a bunch of services that can help remove the undifferentiated heavy lifting for some of the things that were just really difficult to implement on premises. We have identity and access management, IAM. We can define, enforce, and audit user permissions across all AWS services, actions, and resources. There's a bunch of services that kind of help with this. AWS IAM, help you securely manage access to this AWS services and resources. IAM Identity Center, it used to be called AWS SSO, but centrally manage your SSO to access multiple AWS accounts and business apps using your same login. Directory services, use managed AWS, manage Microsoft Active Directory in AWS. We have Amazon Cognito, single sign-on. Organizations, policy-based management for multiple AWS account. AWS Resource Access Managers, a service for sharing AWS resources. We want to make sure everything's authenticated. Set up that least level of permission. Integrate that with your authentication tools like Active Directory or Okta. Make things ephemeral, short-lived. If there's an attacker, we want to make things difficult for them, right? We also have detective controls. Gain the visibility you need to spot issues before they impact your business. Improve your overall security posture. Reduce the risk profile to your environment. Some of the services that help with this: Security Hub, AWS Security Hub, centrally view and manage security alerts. Automate compliance checks. Amazon Guardview, intelligent threat detection. Amazon Inspector, automate security assessments. Amazon CloudWatch gives you complete visibility to your cloud resources and applications. You can collect metrics, monitor log files, set alarms, can automatically react to some of these changes. AWS Config, record and evaluate the configurations of your resources so you can audit. You can track changes of resources. You have an overall security analysis. AWS CloudTrail, you can track user activity and API usage to enable governance, compliance, operational and risk auditing of your AWS account. Remember, everything in AWS is an API. VPS flow logs, capture the information of IP traffic going in and out of your network. Flow log is stored using Amazon CloudWatch logs. Overall, like, this just gives you a better visibility. Look for events and correlate. If we move on to infrastructure protection, reduce the surface area that you need to manage and increase privacy for and control of your overall infrastructure within AWS. We have an AWS Firewall Manager. Centrally configure your AWS WAF rules across accounts and applications. We have a network firewall, deploy network security across VPCs. AWS Shield, that managed DDoS protection. Amazon WAF, the web application firewall, protect your web applications. VPCs, logically isolate your AWS environments. AWS Private Link, AWS Systems Manager. We want to shift our mindset from how these things were done on premises because it's a lot easier to do in AWS. Data protection. So we have a suite of services that are designed to automate and simplify many of the data protection and security tasks. Things like key management or storage of credential management. KMS, AWS KMS, create and control keys to encrypt your data. Certificate manager, provision, manage, deploy certificates for use with your services. Secrets manager, extend your on-premises networks to the cloud and securely access them from anywhere. Server-side encryption, flexible data encryption options using managed keys, your keys. Really, I mean, in my mind, I know that I used to be scared of encryption, right? Cryptography is hard. If I lost my key, I'd lose my data. So now little effort is required to keep that data protected, whether it be in transit or at rest. The next one, incident response. During an incident, we want to contain that event and return to a known good state. All these are important elements of a response plan, and we can help by developing those tools to automate some of these best practices. Analysis and visualization with Amazon Detective, AWS Backup to centrally manage those backup tasks, Amazon Elastic Disaster Recovery, fast, automated, cost-effective way to do disaster recovery. So what's your plan, right? I think it was Mike Tyson who said, everyone has a plan until they get punched in the face. And that's so true. You need to have a plan and make sure that when something happens, you're able to react and respond quickly. Like I said, everything in AWS is an API. Everything can be automated. And then the last one, compliance. So AWS supports security standards and compliance certifications. They help you satisfy the requirements of virtually every regulatory agency around the globe, right? We had things like CloudTrail or AWS Config, AWS Systems Manager to help you patch OSs, create system images, configure secure OSs. All of these things are available and easy to offload to AWS, leveraging these services, making it a little bit easier. And we can use this infrastructure and services and these services to elevate your security posture, right? So when you're in AWS, you gain the control and confidence that you need to securely run your business with the most flexible and secure cloud computing environment available today. AWS customers benefit from the AWS data centers. It's a network architected to protect your information, your identities, your applications, your devices. With AWS, you can improve your ability to meet core security and compliance requirements, things like data locality, protection, confidentiality, all with those services and features that I just talked about. So right now, AWS is protecting millions of customers around the world, large enterprises, startups, educational institutions, government organizations. It's a large group. The scale and global reach of these customers, they give us broad visibility and deep perspectives to cloud security, which we then reinvest back into our infrastructure and services. So every AWS customer benefits from AWS being the only commercial cloud that's had its service offerings and associated supply chains vetted for and secure enough for top secret workloads. AWS is able to help you automate your security tasks. You can shift your focus from scaling and innovating your business back to scaling and innovating your business. Plus, you only pay for what you use, right? The services, they can help you transform the way you do business. They can automate, we can help to automate security and compliance tasks, reduce the risk so you can grow and innovate faster. And AWS has the largest network of security partners and solutions like HashiCorp, like Vault. This helps extend the benefits of AWS by using security technology and consulting services from those vendors and partners that we already know and trust. And a big piece of that, and a lot of what we've just talked about, comes down to the security model. And I'm sure some of you may be familiar with this, but there are two different pieces of it. At AWS, we look after the security of the cloud, and customers look after the security in the cloud. The security of the cloud, AWS is responsible for protecting the infrastructure that runs all of the services. Hardware, software, networking, the facilities that run those services. And then customers, you all are responsible for securing in the cloud, right? That is determined by the cloud services that you use. That determines the configuration that you all need to do to make sure that your environments are secure. So as we start to wrap up, some of the key takeaways that I want to kind of go over with respect to the secrets management. An ideal secret management is not just about the tools, but it's also about the processes, right? So with zero trust, everything must be authenticated. Permission should not be granted by just being in the network. Every single request should be verified, authenticated, and authorized. Just in time. Secrets should only be granted to systems when they need it. Instead of hard coding those secrets in source code, applications should request it when it's needed. Users shouldn't have long-term credentials. They should request things when they need it. Make things ephemeral. No human. Wherever possible, remove the weakest link. And unfortunately, that's us, right? Humans shouldn't have access to machine secrets, especially when that is involved in machine-to-machine communication. And in conjunction with that, automate everything, right? Let the machine retrieve their own credentials automatically when they need it. Remember, everything's an API. Rotate frequently. With rotation being easier, we can also make it more frequent. By doing this, the attack vector gets smaller and smaller. Audit. We should have a clear audit trail of our secrets, which we can then monitor. We know who has access to what and when, right? And then integrity. Increased auditability also ties back to the integrity of our secrets. Another key factor of security is data integrity. Can we trust that our secrets are not exposed? Can we audit the access to those secrets? And then availability. Lastly, and often forgotten, data availability is also part of security. So secrets management should be robust and available for users to use it when they need it. So that covers my perspective on secrets management in AWS. As we know, HashiCorp Vault can help with so many of these things. So with that, I'll pass it over to Mike to go over that portion. Thank you all for your
Thanks,
time.
Dan. Thanks, Dan. And we'll go ahead and switch here. Dan, can you go ahead and stop sharing? It's not letting me grab a hold of the sharing. There we go. All right. So welcome, everybody. My name is Michael Tharp. I'm a staff solution engineer here at HashiCorp. And I want to talk a little bit about Vault today. And really what we want to talk about is how Vault can enhance security for users, machines, and APIs inside of AWS. So kind of starting from a very high level, what we've heard when we're talking to customers, and really this is across a lot of different industries, is we've heard the same thing. Business outcomes and directives are driving their move to the cloud, right? We have to make our applications move faster. We have to reduce our risk. We have to start looking at things like business process alignment. But also with key IT accomplishments and directives, what we see is these business outcomes and IT directives are a great fit for Vault. So combined, these are often what we would define as a cloud strategy for our customers. So if you're not aware of the cloud operating model is really a fantastic way to unify many different parts of your cloud strategy. So you bring the cloud operating model to life by solving for use cases. And we're going to kind of be going through Vault today, kind of really focusing in on Vault, but just understand that Terraform for provisioning or Consul for networking really helps you accelerate your cloud journey and still maintain all of the control that you want, whether that's inside of AWS or even on-prem. So from a high level, these are the three use cases we're going to be focusing on today. We're going to start with, or we're going to cover secrets management and how we're going to deal with secrets, whether those are static secrets or dynamic secrets. We're going to look at encrypting data and how we can make that very easy. And then we're going to look at identity-based access and how we're going to authenticate everything before we allow any kind of access to secrets. So before I go into kind of how Vault works, I think it's important to understand, and I know Dan kind of covered this, but I think it's important to understand kind of what the traditional access model looks like. So when we talk about clients, this can be users, this can be APIs, this can be machines. And traditionally speaking, those clients are given credentials. Usually these are very long-lived credentials, whether it's something like a service account or a config file, maybe an environment variable that has something in there, but it's very static. The clients will use those credentials in order to connect to the system. The system will authenticate and authorize based on those static credentials and then provide the data back. But there's quite a few problems with this. And one of the big downsides here is rotation, right? If we've ever been in a situation where we said, you know what, I'm going to use a static service account. I'm going to use it across my entire enterprise. Maybe you've got a web farm or maybe you've got an application farm. In doing that, and then you say, hey, you know what, we need to rotate. That can be very difficult, if not impossible, and can create significant outage. So this has a pretty huge downside. So when we look at Vault, we kind of change up the way that we're going to deal with getting our clients' secrets. So what we're going to do is we're actually going to put Vault in the middle of that request. Now, understand this works great in AWS. It also works great in on-prem. So if you have, say, an on-prem and an AWS environment that you need to have a consistent workflow for gaining secrets, Vault really helps you solve that in a central way. So with our clients, we have those same clients, right? Machines, APIs, end users, whatever that may be. They're going to authenticate against Vault. Vault's going to use your trusted authentication provider. So whatever you're using today, whether that's IAM, maybe Active Directory, LDAP, GitHub, whatever that may be, Okta, will authenticate that request. Once that request is authenticated, we will then attach a policy, which is what's going to do the authorization. So with Vault, we have the ability to attach policies which are very fine-grained to only allow access to the secrets that we want. Finally, Vault will actually provide the secret, whether that's a dynamic secret where it actually goes out and creates that secret and provides a very ephemeral, short-lived secret, or maybe even a static secret that's stored in the key value store. Returns that information to the client, and the client can then use that to process that application, complete that transaction, whatever that may be. And all along the way, we're going to have audit. we're going to be able to see everything that's going on. Anybody who logs in, anybody who is going to be interacting with Vault in any way, shape, or form will be audited. So I want to start with identity-based access because I think it's really important to understand why identity, right? So I think we all know what the challenge is. There's a lot of different platforms and resources that we're having to manage, and securing across all of these different platforms with all these different resources can be a pretty big issue, right? And the result is very simple. Increased costs and operations, trying to manage and secure all of these resources can be difficult, and the productivity loss of this complexity is pretty evident. We also increase our risk because we have a much larger attack surface that we're dealing with now. We have a much larger estate. And because of this complexity, the chance for breach is much higher. So the solution with Vault provides a unified identity that we natively and securely authenticate and authorize a resource, no matter where it lives. So this unification of identity kind of relieves us of the burden of having to manage all of these different systems and platforms as a unique entity. And introducing unified identity with ephemerality into our secret strategy also reduces our risk across the entire organization. So let's take a look at what this looks like without Vault and then what it looks like with Vault, because I think it's a little bit easier to see in a diagram. So we're going to kind of start off with Alex on the left-hand side. Alex is a user who needs to be able to interact with quite a few different systems. And traditionally speaking, without something like Vault, what we have is we have individual accounts, usernames, passwords, secret keys, whatever that may be, for each of our different systems. So when Alex wants to use GitHub, Alex will log into GitHub using the username and password. Same thing with VMware. Maybe I'm using an access key and a secret key in AWS. Maybe I'm using a JOT token in Kubernetes. But each one of these are individually managed, controlled, and accessed. But with Vault, we look at this a little bit differently, because what we know is Alex in GitHub, Alex in VMware, Alex in AWS, Alex in Kubernetes. Those are all still Alex. And Alex is going to need access to specific secrets based on who Alex is. So with Vault, what we do is we treat Alex as an entity, and we combine all of these different authentications together to be able to provide access to Vault. And this really is that unified identity piece, right? So what we know is, in this example, Bob is AWS, GitHub, LDAP, maybe an X509 certificate, and it creates one logical identity across our entire estate. We also have the ability to do identity groups and really kind of enforce that strict RBAC logic. So I know that talking a little bit about policies and ACLs, ACLs are really how in Vault we use to authorize access to specific secrets, right? So with ACLs, what we're going to do is we're actually going to create fine-grained permissions that say, once we've authenticated, maybe this user is allowed access to a specific secret or a specific secrets engine, as well as being able to say, I want to allow delete, read, update, whatever that may be. And we can also extend ACLs with Sentinel. So if you're not familiar with Sentinel, Sentinel is a policy as code framework. And what Sentinel allows us to do is create enhanced security policies, being able to do things like self-service, but create guardrails. So really, it allows us to take fine-grained controls, but then also create organization-wide controls so that way we're always playing by the rules that we're given by our security and compliance friends. So we talked about a few things here, and I want to call out a couple of different items, right? When we're looking at entities, obviously this is where we're doing the aggregation of all of the different authentication points. And this doesn't matter where it lives. You can, the example would be if you're working inside of AWS and you want to log in with native AWS, and this really comes in handy when we're talking about machines. We're talking about something like a machine. A machine uses its EC2 metadata to authenticate to Vault. Vault knows what type of server that is and provides it access that it needs, as well as identity groups. And one thing I want to call out here is the control groups. So when we're looking at control groups, we actually have the ability to create an additional step for highly sensitive secrets. So we may have an area where we've got a production environment, then we have a highly sensitive, maybe a regulatory environment that we have to be very careful about what secrets or what access we allow into that. So we can actually use control groups in order to be able to create an additional authorization step. something like a manager would have to approve before you can actually be granted that. You can still request it, but it's going to go through a authorization process through management. And obviously multi-factor authentication along the way. We can enforce MFA across all of our different workflows and make this very, very simple. So let's talk a little bit about secrets management and how Vault can help solve that secret sprawl problem. So what we've seen time and time again is that secret sprawl is a genuine problem for many organizations. When you have your secrets spread out over multiple resources, maybe spreadsheets, config files, it really compromises our ability to be able to scale effectively and securely. So this configuration complexity reduces our productivity, increases our costs, but also, because of this complexity, increases our risk of non-compliance and misconfiguration. So with Vault, we have the ability to centrally store, access, secure, and distribute secrets across all the applications and systems, no matter where they live or what method they use to authenticate. This ability is really unique because it reduces the deployment times for our workflows. We want to deploy our application, we can deploy it very quickly because we have this ability to be able to authenticate and centrally store. And ultimately, what we want to do is we want to use things like dynamic secrets and ephemerality, control groups, and some of the things we were talking about before in order to be able to reduce our attack surface and really provide a much higher level of security than even what we were able to do on-prem. So when we look at Vault Secrets Engines allow us to store credentials, things like keys, SSH tokens, whatever that may be, and we can do those statically. We can actually create what are called KV stores. These KV stores can actually store our credentials. We can also rotate those as well and keep all the different versions. So this is really, really handy when we start to say, hey, let's look at Vault and figure out how we're going to move forward with Vault. Another interesting thing that we can do is we can also orchestrate workflows, right? Vault is completely API driven, so we have the ability to do things like dynamic secrets and being able to use dynamic secrets engines in order to be able to create very short-lived ephemeral credentials for a specific resource. So all these things together really help us manage all of our security platform and profiles across all of our different environments. So let's talk a little bit about dynamic secrets because I think this is important. So dynamic secrets from the Vault perspective allow us to create a secrets engine, then deploy a secret to a specific resource, giving it a time to live, how long that secret's good for. And then when that time to live has reached, whatever is trying to gain access to that specific resource will then authenticate to Vault again, request a new secret, and be given a new one. So if we look at this with this diagram on the right here, from an admin perspective, all we're going to do is we're going to say we're going to use a database. So we'll mount that database secret back end, we'll configure the back end, and we'll create a role. Now, roles are really important because we have the ability to be able to create multiple segments that say, like, we've got read, we've got write, and we've got admin. So we can create these roles and assign these roles to all of our specific resources. So from an applications perspective, if we take an end user out and look at it from an application perspective, this is actually really, really beneficial. So that application requests a set of credentials from Vault, obviously authenticating and authorizing before it's going to get access to those secrets. And then what Vault does is Vault will actually connect to that database, create a specific user account for that application, provide those credentials back to that application. And in this scenario, we're talking about a TTL of 1 hour. So that credential is good for 1 hour. So at the end of that 1 hour, what will happen is that credential Vault will remove, and then the application would then re-authenticate, request a new secret, and would do this again and again and again for how many times it needs access. Now, along with secrets engines and dynamic secrets, one of the common questions that I get is, that's great, and you support pretty much every database out there, all the major clouds, but what if I have like a homegrown application and I want that same type of functionality? Well, with Vault, we can actually extend with secure plugins and get that same functionality in our custom applications. So doing this really kind of allows us to keep the same security profile no matter what the application is, and being able to use Vault as that central access point. And obviously, no security tool will be complete without complete access logging. I know I talked about that earlier, but this is all in syslog format. So if you're using something like a SIEM or whatever log management you want to use, it's very easy to take the syslog formatted audit log and actually push that out to your log management system. So we covered secret storage, dynamic secrets, secure plugins, audit logs. One thing I do want to call out is namespaces. So in our commercial version, we have what are called namespaces. And namespaces really are a vault inside of a vault. And this becomes really handy when you're talking about, maybe I want to allow self-service for a specific business unit, maybe an application stack. I have the ability to create these vault inside of vault type scenarios to where I can allow maybe the application team to control what secrets engines they want to use, how they want to store their secrets, actually creating different authentication methods. But with Sentinel over top of that, I can actually control how they do that. So it actually kind of works all together. But these namespaces are really, really handy when we want to create segmentation. And obviously, along with dynamic secrets, one of the questions that I get commonly is, well, I'm creating all these dynamic secrets. Do I actually lose control? No, you don't. Because every time a dynamic secret is created, you get a lease, and you have the ability to revoke that lease. And in a break glass scenario, you can actually remove all of those leases and actually shut everything down so that way you can remediate and then move on. So the next one I'd like to talk about is this idea of data protection, right? And how we can greatly enhance the ability to protect sensitive data. So data protection really seems simple at first. When we start to look at data encryption and say, okay, I want to encrypt my application, a lot of times what will happen is the business will go to a set of developers or a single developer and say, hey, we really need to protect our data. Can you go and find an encryption algorithm to do encryption? A lot of times, and in most cases, it's been my experience that those developers are not cryptographers. So what they'll do is they'll go out to something like GitHub or Stack Overflow, find some code, drop it into their application, not really understanding what the impact of that is. So in this scenario, what we want to do is we want to make that much simpler. With Vault, we make this very, very easy. It's a simple API call. So what we're going to do is we're actually going to make that API call, take clear text, turn it into ciphertext, provide it back to the application so it can write to the database. Now, obviously, being able to do this reduces costs, increased productivity, and reduces risk of data exposure because we're making it very easy and we're not having to go outside of the cryptographic norms. So all this is done as far as the API is concerned with the Transit Secret Engine. And this is how we're going to handle all things cryptography. So if you look on the right-hand side, what you're going to see is you're going to see an application workflow. So I'm going to explain that real quick. If you have an application that is using Vault to do cryptographic operations, essentially what that application will do is when it takes in clear text from the application, it'll then authenticate and be authorized to Vault, use the Transit Secret Engine, provide it the clear text. That clear text will then be encrypted using an encryption key that has a version tag, and then pass back to the application to be written to the database, which means Vault doesn't actually hold any of this data. It's just providing the encryption key for the encryption operations. And then we do the exact same thing in reverse when we want to decrypt. So this is really, really powerful because we're able to take advantage of all the standard encryption options that we want without having to write any type of custom code. Also, when we start to look at things like encryption, this always comes up as PKI. And PKI can be very challenging. So with Vault, we can actually act as a certificate authority. Now, the good news is it can be a primary or an intermediate certificate authority, but this process works in the same way that we're doing encryption or dynamic secrets, the exact same workflow. So what will happen is a machine will authenticate to Vault, be authorized to use the PKI engine, request that a certificate be signed, gets a signed certificate back, and it continues on. Now, along with this comes that idea of ephemerality. So a lot of times, working with customers, what I found is when we're dealing with certificates, a lot of times these get to be very long-lived, even longer lived than some of our passwords. So what'll happen is somebody will cut a certificate for 10 years. And really what that is that's some approximation of infinity to them, right? They'll say, you know what, I'm not going to be here for 10 years, so I'm going to go ahead and cut this for 10 years, fire it up, and then somebody else will have to deal with it. The reality is that really hurts our security profile. And when we go to rotate those, that becomes even more painful because now, just like dealing with things like static secrets and config files, we have to figure out what we're going to rotate, how we're going to rotate them, and then we have to go through and do it. And a lot of times there's going to be outage here. We want to make that very, very easy, the same way we do everything else. So the key here is API-driven encryption, being able to roll your keys as often as you want. We do have FIPS 140-2 compliance. I'm not a FIPS expert, but we have plenty of docs explaining what that is and how that works and how we achieve that compliance. And then one other area that I wanted to cover was replication filtering. So a lot of times when we're dealing with large infrastructures, we're going to have compliance things that we have to deal with. An example of that would be, let's say I'm working in the US and the EU. In that scenario, because of some of the EU constraints, we may or may not be able to replicate certain secrets across to the United States or vice versa. So in that case, we have the ability to not only create a large cluster to be able to centrally manage all of our secrets, but we can also control what gets replicated back and forth. So we can always stay in compliance. And this is really, really handy when we start to look at scale, dealing with things like GDPR and some of these other pieces. So really handy, really powerful. So to kind of summarize Vault from a very high level, really what we're talking about is this idea of being able to do identity brokering, authenticate and access anything that you need, no matter where it lives. And we're authenticating everything. We're not allowing anything to come through based on IP restrictions or like that. Single policy and governance, obviously being able to do secrets management, and then finally data encryption and making that very, very easy. So done quite a bit of speaking thus far. So what I'd like to do is show off a demo and kind of show you Vault in action. Give me 1 second and I will set up my share. All right, so hopefully everybody can see my screen. So on the top, I have Vault and the UI that's provided with Vault. So I'm gonna go ahead and log in there. And at the bottom, I'm gonna do the command line. Now I'm gonna actually be mixing and kind of showing you around, but let's kind of walk through the Vault UI. So obviously in the Vault UI, we have the different secrets engines. That's kind of where we start by default. We have the ability to enable new secrets engines, just like I talked about before, whether it's KV, PKI secrets, SSH, transit, obviously different clouds and different infrastructure controls. We also have the ability to control access methods, and I'm actually going to show you this here in just a minute. And then we have the ability to actually go in and view all of our policies. So let's go ahead and get something fired up here. Let's actually, let's configure something. So what we're going to do is first we're going to do an auth method. So I'm going to do an auth list. And what this does is this shows me a list of authentication methods that are enabled currently inside of Vault. So if I go here and look at my auth methods, right now I only have token. Let's go ahead and change that. So I'm going to enable the auth engine for AWS. Perfect. Then I'm actually going to configure this auth client to be able to use my access key and my secret key to be able to gain access. From here, I'm actually going to write out a role. In this case, I call it my role, but obviously you could create multiple roles with different policies connected, different time to lives. This is infinitely configurable so that way you have what you need for each individual, say, business unit, end user, machine, API, whatever that may be. All right, we created a role. And now what I'm going to do is I'm actually going to set an IAM server header. And what this does is it allows me to even restrict even further where requests can come from. So in this case, I'm doing demo.vault.example.com. We'll go ahead and do that configuration. Now I have created a policy. It's a default policy that allows my user and my AWS user access to specific secrets. So I'm going to go ahead and apply that as well. And I'm going to actually show you what's going on here. So if we go look at our policies, you'll see our default policy, very, very simple, very straightforward. It's all path-based. So I have a path and I decide what's going to happen with that path. So I can kind of look through here and see different capabilities and available. And what I did was I actually updated these down at the bottom to where I have different mounts. So I've got secret data demo and I've got capabilities read, update, and list. So just to kind of show you what that policy looks like, I'm just going to grab the tail end of this, and that's what you're going to see here. The exact same thing that we have in the UI. And by the way, you can do this all from the UI or the command line. I like doing it from the command line because I think it really kind of shows that configuration and the depth of configuration, but we can actually do all of this from the UI as well. Now what I'm going to do is I'm actually going to create a secret. I'm actually going to, in the secret area, I'm going to create a secret called demo and give it a password of vault demo password. Cool. So now I've got that password in here, and we'll actually be able to see that here. So you got demo, and then you've got a password. You can actually go in and look at it. You can copy it, do whatever you like at that point. Now, if I want to retrieve this, just like I did in the UI, I'm actually just going to run vault kv get secret demo. Perfect. I've got my password. Now, in this scenario, what we're using the Vault client to be able to do this, but you can do the same thing with an API call. And so if you have an application that may not be natively aware of Vault, it can still authenticate, authorize, and still pull those secrets without having to make changes, as well as being able to use things like the Vault agent to kind of ease that lift. So I'm going to go ahead and create a KV store called secret classified, and it's going to have a key of user, mic, password, vault, environment, prod, type, server. So I can give many different values inside of a specific store so that way I can keep this information. So I go ahead and post that. And if we go into secret, what you're going to see is you're going to see classified. And again, you're going to see all these different values. And just to show what it looks like from the command line, we've got the actual values. And one thing I want to call out is you'll notice up here, it says version 1. Because remember, if you remember back, I actually talked about being able to use different versions inside of a KV store. So even though these are static, I still have the ability to roll them as often as I need to. Now, what I'm going to do is I'm actually going to log in. So currently I'm logged in as root to Vault. So I have all the permissions that I need to do anything I want. I'm actually going to log in with my AWS auth method using my header and selecting my role. Let's go ahead and do that. Here we go. All right, so now I've got a token. I'm authenticated to Vault, but my access is going to be different because now because of that policy I created, I have a restricted amount of control that I have over the different secrets. So I can still list my secrets. I have the ability to actually get my demo secrets because I'm allowed to do that based on our policy. Obviously, we see version 1. I can actually do an update. So this is actually where we're going to see these multiple versions. So I'm moving demo from and password from Vault demo password to Vault demo password 1234. I'll go ahead and do that. And what you'll notice is that version changes. So now I'm seeing that version 2 is the latest, and I can keep iterating over this as much as I want. So if we go back here and we go into demo password, you're going to see demo password 1234. We've got version 1 or version 2. I can go look at version 1. So very easily, without having to lose anything or suffer any kind of outage, I can actually rotate my secrets, have applications that are still using the old secret if need be, and then rotate them at my convenience. So let's go ahead and get this secret. So I can get the secret demo because I'm allowed to do that. I'm allowed to read and update. I can also get version 1 from the command line, just like I showed you on the UI. You have the ability to be able to bring in version 1 and actually see what that value is. Now, I'm going to try to delete a secret. And what you'll notice is in those permissions that I showed you, we don't actually have delete permissions. So when I go ahead and run this, obviously permission denied. Why? Because I'm authenticated against my AWS auth method. And then what happens is because of that login and the policy that's connected to me, I don't have the ability to be able to do that. And just for fun, let's go see if we can get the secret classified information, which I don't have permissions to either, and I get permission denied. So being able to kind of show how we're authenticating and how we're interacting with Vault. I can't do a Vault auth list because that's an admin function. So I'm really kind of narrowed down to just being able to consume the secrets that I need, whether this is a user, API, or a machine, and being able to move around inside of Vault and know that everything is secure. Now I'm gonna go ahead and remove my Vault token. This Vault token is what actually authenticates me against Vault. So I'm gonna go ahead and just show that I'm logged out here. So I'll do a Vault auth list, obviously permission denied because I'm not logged in. So I'll go ahead and log in. Now I'm logged back in and I'm able to do a Vault auth list. So just kind of showing that logging in, logging out. And I have the ability to go get my secret demo, and I can go delete secrets as much as I want. And then I can also disable the Vault auth method for AWS. So this kind of shows you how we use auth methods. But the next thing I'd like to show you is secrets engine, because I think this is really, really neat. So let's go ahead and go back here. And we're going to go ahead and do a secrets list just like we did before. We can see all of our secrets. And I'm going to go ahead and enable the AWS secrets engine. Very simple. And this will take a second to refresh here. We'll go ahead and force that. So you'll notice I have this here, and there's configuration. So I can do this all via the UI if I choose. In this case, I like to show it from the CLI, but I can go in here and create roles and create configurations, but I'm going to do that from the command line. So go back here real quick. And I'm going to go ahead and write the AWS secrets engine config and set my lease to have a lease time of 30 minutes and my lease max time of 30 minutes. Now, going back to this idea of ephemerality, we have a lease, which means that once that 30 minutes hits, Vault will reach out to AWS and remove the account that I'm using if I hit that 30 minutes. And then I would have to re-authenticate or re-request another account that gets created, right? And as well as we have a lease max. The easiest way to think about this is how many times can I renew? So right now I have them both set to 30 minutes, but let me give you a for instance. Let's say that you're working with a contractor and a contractor needs access to specific resources. So what you may do is say, hey, you know what? I'm going to give you access for 30 minutes, but that's good for 24 hours. And what happens is at the end of that 30 minutes, you have the choice of renewing that lease without it having to give them new credentials. And they can keep using that for something like 24 hours, 48 hours, whatever that may be. So it really gives you that flexibility of having ephemerality without having to create a lot of overhead in your workflow. Let's go ahead and create that. And then we'll do where we're actually going to configure the AWS secrets engine to be able to authenticate against AWS, so that way I can actually create those accounts. So I'm gonna go ahead and do that now, working in region US East 1. So like I said before, I'm gonna go ahead and create a role. Now these roles, again, are specific. So I can create many different roles to be able to have different access. So in this case, what I'm doing is I'm saying, I'm gonna go ahead and create a role called my role. And this is going to use the AWS policy documents. And the advantage behind this is there's a lot of examples that AWS already has. So you can actually take those and use those directly here to be able to create the roles that you want with the permissions you like. I'm also going to do a Vault IAM list users. And what you're going to see is there's just a Vault demo. So we'll go ahead and leave that there. Now, what I'm going to do is when I want to access the secrets engine, I have the ability to be able to just do a read and tell it AWS, which is my secrets engine, the creds, my role for the specific role. And what's going to happen is when I go here, it's actually going to reach out to AWS. It's going to connect to the IAM service, create a specific user account for me with a secret key and a access key, provide that back to me, and that's going to be good for 30 minutes. At the end of 30 minutes, if I don't renew that lease, Vault will actually go back out and remove that lease or remove that account for me from IAM, and then I can re-authenticate and do this again. So when I look at list IAM users, what you're going to see is you're going to see this right here, Vault token, my role, and then a unique identifier. That shows inside of AWS actually what's happening. Vault's reaching out, authenticating against IAM, configuring that account for me, providing me back my access key and secret key so that I can authenticate and move on. So actually, let's go up here and look at this. And what this looks like from a UI perspective is something very similar. So we did all this via the command line, but I have my role and I can actually go through here and I can actually generate. And what will end up happening is I get the same exact thing that I had before from my AWS account. And I can copy this lease ID. Right, and let's say I wanted to go revoke this. I can actually go through each one of these, go to my lease, AWS, creds, my role, and then I can find that specific one and revoke. Right, so I can choose what I want to revoke and go from there. So let's go ahead and go back to the command line, and I'm going to show the exact same thing. So there's different leases we have, and I'm going to go ahead and revoke. All right. I revoked. So what we're going to see is we go back here. We're going to see that that lease has now been revoked. So I don't lose control by creating this automation. In fact, I have more visibility into what applications are actually using specific secrets or specific authentication engines because I have the ability to look at leases and actually be able to revoke them. Now I'll go ahead and disable the Vault secrets for AWS. And what you'll see is this will actually go through and it will actually go through and remove that. So if we go back here, what you're going to see is the AWS secrets engine is no longer available. All right. So that really is the end of the demo here. Let me go ahead and bring back up my slides. All right. So what's next? Showing a demo, talking a little bit about Vault, that's great. But what we like to do is we like to have everybody get their hands on Vault. And what we're going to do is on May 10th, we're actually going to have a hands-on workshop. What this is a longer session where you'll actually have HashiCorp and AWS TAs inside of a workshop. You'll have a sandbox environment you can work in, so that way you're not having to work in a production environment, and actually be able to use Vault with all of these different things that I talked about today and even more than that. So if you want to register for that, the link is down at the bottom. That's 12 p.m. to 5 p.m. EDT. As well, we are going to be at Reinforce, so we always encourage everyone to stop by the booth, say hello, maybe get some cool stickers. We'll be there June 13th and 14th. So yeah, I want to thank everybody for their time. Hopefully this was informative, and I will turn it back over for Q&A.
Looks like we got quite a few questions in the Q&A chat, so I'll let you all go ahead and attack those.
Cool. Yeah, I'll just start at the top here. I think a couple of them got answered, so we'll just address those. But first question at the top of the queue, at least, will you get the presentation slides? So yes, we'll go ahead and supply those. You are using the term unified identity. What do you mean by that? And then do you mean a single source of identity? So I don't know, Mike, if you have any insight into that.
Give me a second, pulling up Q&A here. So talking about unified identity, what do you mean by that? So when we talk about identity from a Vault perspective, what this means is it goes back to that idea of an entity, right? So an entity is all of these different areas, right? Whether that's GitHub, whether that's IAM credentials, that entity is really what, like in the example we had where we had Alex, that Alex is all of those things, right? Alex has to be able to get to gain access to things like GitHub and AWS and VMware and Kubernetes, but that's really just Alex. So when we talk about unifying identities, what we mean is each one of those identities can be used to authenticate against Vault, so that way I can get the secrets I need no matter where it lives. And that's really what we mean by unified identity.
Awesome. Yeah, and I think that ties in with a question a couple down. It says, for a unified identity, is that a similar concept if I'm using Okta? Should I integrate Okta with the solution or migrate out of Okta?
Oh, you don't have to change your authentication sources. Just to be very clear, you don't have to change your authentication sources. In fact, I would say you don't need to move away from Okta. You can actually use Okta to authenticate your resources to Vault to be able to get your secrets. So, and the same goes if you have Active Directory, or LDAP, or whatever that may be, you have that ability to be able to use what you're already using today. So that way you're not disrupting that workflow, but just tying Vault into it.
Yeah, same thing. I mean, from the AWS perspective, right? Like those are just going to flow in. You can use whatever you like. It integrates with Vault, with AWS. Like no need to change out from anything you're currently using.
So I noticed there's one that says you mentioned RBAC.
Yeah.
And how do entities relate to RBAC roles? So when I authenticate as a specific entity, I have the ability to then create groups or individual controls based on that individual's identity. So like I said, Alex is GitHub, Alex is AWS, Alex is Kubernetes. What we know is who Alex is and what Alex is supposed to have. So what we're doing is we're actually doing that role-based access. And then we can start to group those together just like we do in Active Directory. We can create control groups to be able to say, hey, you know what? I'm going to group all these folks together. And then what we're going to do is we're going to authorize this entire group to be able to gain access to it. So that's really what we mean by RBAC.
Yeah, let's see here. I saw that Sven got his question answered, but we'll go ahead and ask it anyway. Can you or can the backend roles be imported from something like AWS IAM? So in the event I wanted to maintain parity between my AWS roles and Vault roles, and yeah, I think you walked through.
Yeah, I mean, I think we're good there, but yes, you can there's different ways that you can lay out roles and access controls if you want to import those in. Obviously, there's the API, so you can actually just compare and then push it directly to Vault if you choose, making that really, really easy. So for HashiCorp, would you be able to explain how Vault and Okta would work? Would you still set up all the apps in Okta, or is it Okta only needed for authentication of all the access to the apps that are handled within Vault? This is a great question. So there's a couple different ways, right? So we have an OIDC provider that you can actually use to authenticate. If you're using OIDC, that's most common. But there's a lot of different options here. If you're using the OIDC provider with Okta, that seems to be the most common. But if you wanted to set up something where you're using Okta for maybe internal resources, and then maybe you said, hey, you know what, I'm gonna use AWS IAM for the AWS stuff, you would be able to do that because, again, we're putting all those entities together. So no matter how you log in from these different platforms, you're actually able to authenticate to Vault and get the secrets you need.
Awesome. Let's see. Yeah, this next one from Suja is good, I think. In a distributed environment or containerized application, how do we manage the secrets, including storing and distributing to different components without any compromise? So how do we manage the secret rotation without any disruption to the application and solution? We want the solution to handle the audit trail and monitoring.
So let me cover the first one. Dan, you might be able to kind of talk about CloudWatch and some of the other options that we have, because we can actually push Vault logs there. But talking a little bit about secret rotation, specifically with Vault, when you talk about a distributed environment and managing all of those secrets, essentially what can end up happening is if you're using something like Kubernetes, we can actually take the Vault agent and we can do it as a init container or sidecar. And then what happens is the application uses that sidecar or init container to essentially reach out to Vault, authenticate, probably with a JOT token at that point, get the secrets it needs and pull it back into the application and make that available. Obviously, with a init container, you would have to restart the entire container process, but with Sidecar, it's always available.
Yeah, and then with CloudWatch and CloudTrail, because everything is an API and everything's being called within AWS, there is an audit trail for all of those calls. Anytime anything is happening, you would probably just have to set up the alerts that you were looking for, or be able to export that. We see a lot of folks kind of just dumping that out into a lake that you can kind of do reporting on and monitoring on.
And one other thing I want to cover on here, I don't know if we have a question about this, but the way that we can implement Vault is there's basically 3 different ways that we can implement Vault for an application. So the gold standard, the best way to do it is to actually write it into your application. But the reality is that generally takes time. So most customers aren't going to start with, hey, I'm going to refactor all my apps to be able to use Vault. What they're going to start with is something like Vault Agent. And that's where I talked about Sidecar or init containers, being able to use the Vault Agent to authenticate against Vault and provide those secrets in, say, a direct injection to a config file that only is available in memory, or we can dump them out to a file if we want to. I wouldn't recommend it, but we can, or we can take them to environment variables. Again, you can get those via an env command. So, but ultimately that Vault agent is kind of the key. Now we can also do API. So if you say, you know what, my application really we don't want to refactor our application, or maybe it's an out of the box application where you can't really do that. What you can do is you can integrate via the API and actually get that same functionality. So essentially you just have to be able to authenticate and then make that request to the secret. So when we're talking about something that's ephemeral, it's going to work the exact same way and really enhance that security position that you have.
Awesome. Yeah. And then I think Welly posted in the chat, there is, if you're using Kubernetes, there's a, on the HashiCorp site blog, there's a Vault secret for using Kubernetes integration as well. So that resource is also available.
I see Tony asked about FIPS. Again, not a FIPS expert. In fact, what I would like to do is I can actually provide the link where we explain all of the FIPS compliance and how we obtained it. So it explains all the primitives. It explains all the connective tissue that comes along with FIPS. Unfortunately, I'm not I'm not an expert in that, so I don't really want to speak to that. I'd rather just point you towards the documentation. So we'll make sure that we get that in there as well. We'll see if we can't put that in chat.
Awesome. Let's see, is we have to report user access rights regularly. Do we need to download the policy JSON and scrape that to build a report, or is there a report builder included?
So as far as a report builder inside of Vault, there really isn't reporting like that. So you would either need to take the policy or use the audit log with whatever SIM you're using, and you should be able to narrow that down to be able to provide those reports. Most commonly, that's what I've seen customers do, is just use whatever logging tool or SIM tool it is and say, hey, here's a snapshot of my audit log, and usually auditors are okay with that. In fact, it's usually more detailed than they even want, but it's good to have to be able to say, hey, I'm not hiding anything here. Does the required parameters option work for KVV2 policies now? I believe so, but let me verify that. I know what you're talking about. Let me verify that. I believe that it's working appropriately. Let me verify that.
Right.
So it looks like asking about demo on enabling secrets engine. So the demo that I had actually did the secrets engine and the auth engine. And actually, what I would recommend is that hands-on workshop where you'll actually be able to do it yourself in your own environment. You're in the console, you're typing commands. It's in a completely sandbox environment. So yeah, that demo actually does show off the auth method and the AWS secrets engine. But if you actually want to do that yourself, I would highly recommend coming to that hands-on workshop.
Yeah, I played with it. It's pretty slick how it does that, and you did walk through it, but yeah, that's pretty cool functionality.
Yeah, it looks like Sven. All right. Oh, cool. So we were able to answer those questions. That's awesome. Can we get the PowerPoint? Yes, we'll make that available. Repo URLs. If you want in fact, let me just do this. I can put, if you want to see this demo, I can actually github.com/mtharp. And then what we'll do is we'll go here, Vault. This is a public repo that I use. It just shows the demo that we're using here. So let me go ahead and post that. Where's repo URLs? Type the answer. Here we go. Yeah, you can actually look at the demo that I was running in that link, and you'll be able to actually go through and see kind of what I was doing along the way. Yeah. Unified identity question that was answered sufficiently. Cool. Well, how should be able to manage key value credentials in AWS KMS and not crypto keys? Yes. So we have one of the really cool things is KMS is really handy when we start talking about Lambda and other such things. KMS is really handy when we're talking about AWS native. So Vault can actually manage KMS so that way, what you can do is you can actually create the exact same workflow, no matter whether it's on-prem or in AWS, and you can still get a KMS key that you can use inside of AWS, which makes it really handy because you're using that same Vault workflow, but we're actually managing KMS for you. So yes, absolutely. All right. So it looks like when we talked about AWS Secrets Engine, did you mean that we use Vault as an interface to create the secrets that are actually stored in the AWS Secrets Manager? No. So when we're talking specifically about the Secrets Engine for AWS, what that does is that actually it gives you the ability to be able to create IAM users inside of an account with Vault and make those ephemeral. Those secrets are actually stored inside of the Vault Secrets Engine in the leases, like I showed you earlier, and yeah, that's kind of how we handle that. So it's not actually storing anything in Secrets Manager.
Traditional building blocks in AWS for getting secrets from, or for example, a Lambda function is to attach the IAM role to the Lambda to read an AWS Secrets Manager secret. When adopting Vault, what needs to change? Can I continue using the same IAM roles now to now authenticate to Vault and access secrets? That was Jose's question.
So Let me see here.
I can probably chime in
So
here. Are we looking at the question about Lambda right now, Mike?
yep.
Yeah, Jose's.
All right. Yeah, I think there's a good article about the Lambda extensions that you can use to integrate Vault with Lambda. And in that sense, like the extension itself is the one that making a call to Vault. And yes, it does use the authentications instead of the IAM itself to do that. And then it uses that to retrieve key values. And the nice thing about that is then you also have the catch mechanisms within the extension itself to improve your latency. Of course, like when we talk about Lambda functions, typically we're talking about thousands of executions in minutes, and it's a good idea to catch your secrets in the extension itself rather than keep making the same call to Vault. So I posted on the link on the chat as well.
Awesome. Thanks, Willie. Looks like Tony had a question. Can Alex, talking about Alex and the unified identity from before, operate as, say, an admin sometimes, but not as an admin at other times, and kind of limit the potential of mistakes? So there's a couple of different things you can do here. The short answer, the simple answer is yes. How you go about doing that, it depends on the mechanisms you want to use. You can use something like control groups in order to create, say, hey, here's all the things that you get as a standard user, and then as admin, you put them as a member of control group, and they have to actually provide additional authorization to be able to gain access to those. That's most commonly what customers will do. But there are a couple different ways you can do that. You can enforce MFA on certain things, right, and allow that MFA to happen, so that way when you authenticate, you're essentially using MFA and proving that you're ready for those admin roles. So there's a couple different ways you can handle that, but ultimately the answer is yes. All right. In an on-premise environment, can Vault operate as an identity service like LDAP or Kerberos, or is it just middleware for the existing services? This is a great question. So Vault will not be. So Vault does have local user accounts that you can create. So if you wanted to use Vault as a local user account, you could. It really, what Vault is designed to do is it's designed to take advantage of whatever identity services you're already using. So we don't want to try to reinvent that wheel. What we want to do is we want to use what you already have, because you've got a workflow built around that. So we don't want to change that workflow. We just want to integrate that into our secrets management process. So, obviously, can Vault authenticate you with a local account? Yes, it can, but in most cases, you're going to use something like Active Directory or LDAP or Okta or whatever that may be. So it looks like, do we have more explanation on what I should use when I should use Secret Manager, when I should move to Vault? Is Vault more powerful? Secrets managing tool, but Secret Manager is just better if you don't need to integrate with too many systems and only in AWS resources. So you kind of hit the nail on the head there. So with Vault, obviously we can run Vault on-prem. We can run it in all your different cloud premises and provide you that singular workflow. The advantage behind that is no matter where your applications are getting deployed, they always have the ability to get their secrets. Secrets Manager is a fine tool. And if you're only in AWS, you can use Secrets Manager. But the difficulty then becomes, how do I deal with everything else? And that's really the answer that we look to solve, is how with Vault, we actually help you answer that. How do I deal with everything else? And so in many scenarios, that's the reason why customers will look to Vault, because it's not just maybe one AWS environment. Maybe they're using multiple on-prem data centers. Maybe they're even using another cloud. In that scenario, we actually have the ability to be able to span all of that and provide you one singular workflow, no matter where the application lands.
Yep. Is there a way to integrate Vault with Kubernetes secrets and have Kubernetes reload pods when secret changes or gets rotated inside vaults?
So you want to actually keep the secrets in Kubernetes? I think that's what's being asked. Traditionally speaking, obviously you can store those in Kubernetes, but generally you're going to want to use something like an init container or sidecar and go directly to Vault and authenticate. That way you can guarantee that similar workflow. Most of the time you're not going to want to store those secrets there, especially if their application are highly sensitive. We actually want to back those with Vault. So Yeah, hopefully that answers your question. I think that's what you're asking is, do you want to do that? No, you generally would want to use Vault for that. We got another Lambda question. It looks like, is there something similar to Vault Agent for AWS? Yeah, you should see that link. It kind of talks about the Lambda extension and how that's used.
Yeah.
AWS Vault storing password is secured way or encrypted. I'm not sure I understand that question.
Vault storing, is that when you use the entity to create the password? Was that encrypted or plain text, I guess?
Sure, I can actually cover that. So when we create those secrets, obviously we have to be able to authenticate to AWS. So Vault is actually going to store that secret key and access key so that it can actually connect to the IAM service and create those users for you. So yes, it would be stored inside of Vault. Everything's encrypted. Everything is controlled as far as access and completely encrypted. So there shouldn't be an issue there with that. Yeah, let me see if I can find give me 1 second. Let me get that FIPS document. All right, so this is actually the announcement. Let me put this in here. There's actually quite a few links in here that are available. And this will kind of give you the rundown of the FIPS 140-2 compliance, as well as kind of how we achieved it and what we've documented as far as that concerns. So hopefully that's helpful.
What is the way to run Vault in AWS, EKS, EC2? I think it's up to you as to how you want to run that, but there's also the option of running it in the HCL as well, right? Which I think would be
HCP. So with HCP, when we're talking about running Vault as an enterprise service, HCP makes this very, very easy. You can go into HCP, you can deploy a Vault cluster to manage all of your AWS, all your AWS platform stuff, and you can actually create that direct VPC peering link. So that's generally the easiest way. There's a lot of different reference architectures that we have available. Vault is very robust when it comes to how many secrets are you managing? Are you managing encryption? So you kind of have to scale up on that, but there's a lot of documentation that we have out on our site that kind of talks about that. But you can do it via containers. You can do it via standard hosts. If you want to put it in Kubernetes, that's fine. So yeah, there's a lot of different options there. But yeah, just check out the documentation, and what you'll find is the different implementation techniques that are available.
See, there's mention in an answer that the Vault agent can write the secrets to application memory. Is that the case? Because I thought the agent used a templating to write tempfs volume to a file that the application can read.
That's correct. So I try to keep it from a high level, but yes. So essentially what we're going to do is the Vault agent has the ability to really offer secrets in a couple different ways. Most commonly, what customers will do is they'll actually template their configuration files using a Vault template. And then what will happen is the Vault agent will then authenticate, grab those secrets, and then at runtime, we'll actually fill out that information via tempfs. So yes. Good call out. Can the database secret engine rotate password for privileged users used to manage ephemeral users? So you're talking about can I rotate those passwords? Yes, you can. So I'm not sure if you mean in an automated way, or because generally speaking, yes, you can do that. You can actually go in and rotate, like something like in Oracle, you want to manage the SA account, you can actually manage the SA account. And then have Vault actually do the rotation for you. And if that SA account's then what you're using to mint those other privileged user accounts, you can definitely do that. I'm not sure. So the question is, do we need KMS engine to do it? And is it a separate license? I'm not sure what that's in reference to. I apologize.
Yeah, I'm not sure about that question either.
Yeah, was that in, I don't remember. I don't even know which question that was in reference to. I apologize. All right, so one of the questions is talking about JOT tokens and K8s clusters. I'm not necessarily a containers expert, but what I can tell you is that there's quite a few different ways that you can authenticate, and obviously JOT tokens are one of them. I'm not exactly sure. I'd have to go look at the documentation because I don't spend a lot of time in Kubernetes on how to actually get that JOT token. Dan, unless you know.
No, I'm not a
Yeah,
expert.
I'm
Unfortunately.
not exactly sure how you get it. I just know it's there. And when I set up the authentication, I actually set up a JOT token, and it kind of walks me through that. I had to go read the documentation. If you go look at our documentation around Kubernetes, you'll actually see how to gain that JOT token and how to authenticate with it. Can we have some kind of resource quotas or limits on namespace level based on lease duration counts, etc.? Can you briefly describe how to cache secrets while using EKS so not to overwhelm Vault with repeated calls? Resource limits, resource quotas or limits on namespace level based on lease duration. So we can set some quotas inside of Vault. The one that's catching me is based on lease duration. So I don't know that we can do that. We might be able to extend with Sentinel and provide some additional, but that would be a unique scenario. I would have to delve into that a bit deeper to be able to give you a really real strong answer. And as far as caching, if you're using Vault Agent, it does provide some caching available to you. But Vault's meant to handle those calls, so I would not be too worried about overwhelming Vault, because when you build a cluster, you're going to build it based around the amount of calls you have. So getting more ephemerality, making more frequent calls would actually, in my opinion, be better, because we're kind of keeping those secrets moving. We're not actually storing them anywhere locally. We're just using them for that time being. And when we recycle the application, it actually authenticates against Vault and gets its new secret.
Just real quick on that as well. I think the Vault secret operators really is the native way to do that as well, where it just inject the secrets directly, so you're not making active call to the Vault server itself. It's still in the preview beta at the moment, so we do love to hear feedback from the customers and how you thinking about using it.
Yeah, that is a newer piece that is in beta. So yeah, if you'd like to give that a shot, that might be a little easier. I haven't run into a scenario where Vault's really getting overwhelmed with calls, whether it's from a EKS, ECS, anything like that. And usually it's not a big deal. AWS secrets storing in Vault.
I don't think they get stored in Vault. I think Vault has the ability to pull the secrets, but
if you're talking about the secrets engine, right? Essentially, what's happening is when I request an account or request access to AWS, Vault will reach out to the IAM service, create an account based on that account profile and the account document that you have for AWS, and then provide those credentials back. We're not actually storing that. Well, the only thing we're storing is the lease. So we have the lease so that way you don't lose control of it. You can actually go in and remove that. And essentially what happens is the Vault reaches out and says, hey, I want to remove this user account from IAM and remove it. So it's not actually storing them there. It's just interacting with IAM service.
Yeah, I wonder if that next one is related also. It's EMS and KMS. So I'm not sure necessarily what the...
Yeah, I'm not sure. I apologize. I'm not I don't really understand the question. As far as KMS is concerned, when we integrate with KMS, essentially Vault's just handling the creation and deletion and rotation of KMS keys. So they're still stored in KMS, and you can still use them natively. So if you have something like Lambda where you're using KMS keys, you can actually just pull them directly from KMS and let Vault do the rotation. But with the Lambda extension, it actually makes it really easy to go directly to Vault. So, you know, that may actually be a better scenario. Depends on your application. Can a provision Vault cluster Terraform with Nomad driver Docker securely? Can a provision? So I'm not sure I understand the question, but you can use Vault directly with Terraform. In fact, most customers do. So if you're using Vault today and you want to essentially create ephemerality around a specific run, let's say you're going to actually use Terraform to deploy something to an AWS environment. What would happen is you would use the Vault provider, and that Vault provider would reach out to Vault, have it mint you a account, use that account for the creation, and when it's done, it hits that time to live, Vault will go remove that for you. So I hope that answers your question. And yes, you can actually integrate it with Nomad as well. Nomad has the ability to integrate with Vault directly as well. So one of the questions seems to me that the biggest value of Vault's usage is ephemeral access leases and so on. The possibility to make access more granular, correct? Yes. So there's quite a few benefits here. Obviously, being able to authenticate with whatever authentication method you have available to you. The example I always give is an EC2 service, right? So let's say I've got a web server running EC2. I want to use EC2 metadata, but maybe I'm running that same exact web platform in VMware. I don't have EC2 metadata, so I can log in via another method, right? I could use Okta or whatever I want to use. Ultimately, with Vault, in our ACL policies, we have very granular controls. So I can say what secrets you're allowed to have access to all the way down the path, because it is based on path. So I can say, hey, you have access to all the secrets, or you have access to only this one secret, and you can only read it. You can't even list it. You just have to call it directly. Or I can say you can update it. So there's a lot of different ways we can break that down. But yes, it is very granular. And you can control that granularity, per authenticated user. Key management service.
Oh, that may have been related to the question earlier. So the KMS, and maybe it was CMK that was supposed to be in there for the customer managed key.
So essentially what kind of going back to what we're talking about KMS. So Vault can actually handle the creation, update, and rotation of KMS keys, so that way you can actually use them natively if you choose, or you can go through Vault in order to be able to retrieve those. Given an application that requests secrets to Vault, what would be the recommended way for this app to authenticate against Vault, and where would its auth token should be stored or retrieved from? It depends on where you're at. So there's the three different ways, traditionally speaking, that we can handle, or applications can get Vault secrets. Is one, the Vault agent, which is where almost everybody starts. So the Vault agent will essentially run on the machine, and you will define an authentication mechanism, and then you'll authenticate, and then those secrets will be made available to you. There's quite a few different ways there. The next one would be an API. So if you have an application, like I said, that you can't necessarily edit, maybe the API is the way to go for you. But the gold standard is really to use the SDK, the Vault SDK, and write it into your application and make your applications Vault aware. Like I said, most customers don't start there. They usually start with, let's start with Vault Agent, maybe work our way up to the SDK. But yeah, there's quite a few different ways there. Are there any plans to add Vault Injector sidecar for K8 as an EKS managed add-on?
I can maybe answer that.
Yeah.
Yeah, there's just been the discussions about it. So we are currently looking at several options, including like the EKS blueprint, for example, for Terraform. It's been highly popular. The Vault as an add-on is already there, but I think this is specific for the sidecar injection itself. We do love to hear more feedback about it. So if you do have a use case for that, please reach out. You can contact us either on the GitHub repo itself, or you can just reach out to your HashiCorp rep as well, or your account team on AWS side for that matter. That's something we've been thinking about it, but we do like to see whether the vault secret operators may be the answers to all of it, rather than having like a vault injector. But we realize there may be a use cases where you still want to have other functionalities that it does not cover by the vault secret operator today.
Awesome. Thanks, Willie. It looks like the next question is about the Vault SDK and AWS SDK, any version compatibility. They're separately managed SDKs. So they're not the same. Obviously AWS manages their SDK and we manage the Vault SDK. So I don't know don't know what you mean by compatibility, but they're pretty standard SDKs. In fact, with Vault, I think we cover pretty much every programming language known to man to be able to write that directly to your application. So that should be very helpful. And then obviously AWS provides the same.
Perfect. And I think we're at time now. So, and we may be out of questions as well. I think Fiona did post a link to the survey in the chat. So hopefully you all are all able to kind of complete that. We love to get feedback and see if we can improve this in any way. But any final thoughts, Mike?
No, just take a look at that survey link, fill it out. We would much appreciate that so we can get that feedback. And thank you all for your time.